Hey guys, Mr. Milton here. Today we're going to start our third chapter, parallel lines, and we're going to start with properties of parallel lines. Okay, at the end of this video you should be able to identify the three types of angle pairs formed by a transversal, and you should be able to use angle properties of parallel lines to find missing angles. Alright, we'll start with the vocabulary word. Transversal. A transversal is a line that intersects two or more coplanar lines. Transversal. That's an A. Okay. Alright, and so as you look at this diagram below, we have three lines, line T, line L, and line M. Notice that line T intersects line L and line M. So that means that line T is the transversal. Okay, that's the transversal. It's the line that intersects two or more coplanar lines. Alright. There are three types of angle pairs that are formed by the transversal. So you see all the different angles that are now made because T intersected L and M. Well, there's three types of angle pairs that we'll focus on. Okay. Those angle pairs are alternate interior angles, same side interior angles, and corresponding angles. Alright, so let's talk about alternate interior angles first. In the above diagram, which angles are considered interior? Okay, inside of the two non-transversal lines. So if you notice, T is the transversal, we have line L and line M. Inside here, the interior angles will be 1, 3, 4, and 2. Those are both inside both L and M. Okay, so we have angle 1, angle 2, angle 3, and angle 4. Okay, all of those. Just in numerical order. Alright, now those are just interior angles. Those aren't really our special pairs. Our special pairs are called alternate interior angles. So we've kind of identified, we have identified the interior angles. Which ones do you think are considered alternate interior? Okay. And so if you look at alternate interior, that means they're inside and they're on alternate sides, alternating sides. So you should see that angles 1 and 2 are considered alternate interior. And then you should also see that angles 3 and 4 are considered alternate interior angles. Okay, inside the two non-transversal lines and on changing or alternating sides of the transversal. 3 and 4. Okay, 3 and 4. Notice how these angle pairs are on alternate sides of the transversal. There we go. Again. Inside the two non-transversal lines and on opposite sides or alternating sides of the transversal. Alright, same side interior angles. Which angles are considered same side interior? Again, we've already talked about where the interior angles are. Same side interior angles, then they're just going to be angles that are on the same side. And so you'll notice here that for same side interior angles, we have angles 1 and 4. As a pair of same side interior angles, and we have angles 3 and 2 as a pair of same side interior angles. Okay, inside the two non-transversal lines on the same side of the transversal. Notice how these angles pairs are on the same side of the transversal. Okay, so far our names are really creative. I don't know if you get sarcasm on that closed caption if you're watching it that way, but not very creative at all. Okay, and then finally, corresponding angles. So corresponding, I always like to think of as being in the same position. Okay, so which angles are considered corresponding? Well, if we look at angle 1, I'll just use my pen. Angle 1 if you really look at line T and L, is the bottom left corner. Okay, I'm just going to circle it. Okay, now corresponding with M and T, it should correspond with the one that's in the bottom left corner, 7. So angle 1 and angle 7 are corresponding angles. Okay, angle 2 is in the top right corner of the transversal and its line. I'm going to square it. And so it goes with, instead of being on line M, we'll be on line L with angle 6. Okay, angle 3 is in the bottom right corner of T and L, and so it will correspond with the angle that's on the bottom right corner, which is angle 8. And then angle 4 is in the top left. I don't have any other one like a squiggly thing. Okay, angle 4 is in the top left of the transversal and its line M, and so it will correspond with the one that's in the top left of the transversal and its line L, which is angle 5. Okay, so corresponding basically means in the same spot for the other intersected line. Alright, so notice how on all these angle pairs, one of the angles is made by the transversal and line L, while the other angle is made by the transversal and line M. Okay. Classify each angle pair from the diagram. I'm going to walk through the first 2 with you and leave the last 3 for you guys to do, so please do these last 3. So, angle 1 and angle 3. Okay, just looking, we need to identify our transversal. That's the line that intersects the 2 lines. So here would be our transversal. So 1 and 3 are inside our 2 intersecting lines, and they're on the same side. So we will call those same side interior. Okay. Angle 5 and angle 6, you'll notice that they're not both inside. Okay, so that means that they can't be alternate interior angles and they can't be same side interior angles because they're not both interior. But it doesn't mean they have to be corresponding. We have to always make sure that we check that it works before we just say it or do an elimination kind of game. But here, if you notice, this is the left of the intersection. If we go left, up, right, down, okay, and then 5 is on the left of the intersection. So they are in corresponding spots, and so they are corresponding angles. Alright, I actually will do number 3 with you. Okay, number 3, if you look at angle 1 and angle 5. Angle 1 and angle 5. Hopefully you notice that we didn't really talk about this type of angle today, but we have talked about it just recently at the end of the last chapter. These are vertical angles. Really important for us to keep up with our vocabulary. Vertical, vertical, I'll say vertical. Okay. Keep up with our vocabulary, the things that we learn, because in geometry, everything that we do, we're kind of adding to our toolbox to use later down the road. Vertical angles being a big piece of that. Okay, all right. So, do 4 and 5 for me, and we'll look at it tomorrow. Okay, flip them to the back side. Alright, so we talked about identifying angle pairs, and now we're going to talk a little bit about a more specific situation. Okay? When a transversal intersects 2 parallel lines, P-A-R-A-L-E-L-L. Okay. Okay, parallel. Nope, it should be L-L. And then 1 L, parallel. Yeah, that makes sense. Okay. Special relationships between the angles occur. So let's look at those. Corresponding angles postulate. It says if a transversal intersects 2 parallel lines, then corresponding angles are congruent. Congruent. Okay, we could also use that congruent sign. All right. So they tell us here with these arrows indicate that line L and line M are parallel to each other. And it says since L is parallel to M, then we can conclude that angle 1 is congruent to angle 2. Notice that they're corresponding. This is in the top right. This is in the top right. Okay, so they're in the same position on line L and line M, that we can say that their corresponding angles have to be congruent since L and M are parallel. Okay. Alternate interior angles theorem says if a transversal intersects two parallel lines, then alternate interior angles are congruent. Congruent. Okay, again, we could just use this congruent symbol if we'd like. And we're going to go through a proof here just so we can make sure that we know that this will have to work. Alright, so quick thing about proofs, we are trying to prove the alternate interior angles theorem. So that means that we will not be using the alternate interior angles theorem to prove itself. It doesn't make sense. Okay, so, well, it doesn't logically make sense. So let's look at this statement. It says A is parallel to B. And so we know that A is parallel to B because they drew these arrows for us. So they told us A is parallel to B. It's given. It's given information. Then it says that angle 1 is congruent to angle 4. Well, we know angle 1 and angle 4 should be congruent because of the corresponding angles postulate. Corresponding angles postulate that we just talked about in the previous step. Okay, now we have that angle 3 is congruent to angle 4. You'll notice 3 and 4 right here. These are vertical angles, so we can say that they're vertical angles, just like that. Vertical angles are congruent. Okay, we know vertical angles are congruent. And then it says that angle 1 is congruent to angle 3. If you notice the line of reasoning, 1 is congruent to 4, 3 is congruent to 4, so 1 is congruent to 3. That is our transitive property. Transitive property. Alright. Next, same side interior angles. If a transversal intersects two parallel lines, then same side interior angles are supplementary. Remember that supplementary means that they add to 180. Okay? Alright, so if we look at this, again, they gave us a situation where A is parallel to B. They told us that with those arrows, so that's given information. Angle 1 is congruent to angle 3. Again, those are corresponding angles, so our corresponding angles postulate is what we'll use. Then it says that angle 3 plus angle 2 is 180. Alright, and that can be our angle addition postulate. Right, because we have two angles that make a straight line, we know it has to equal 180. And then it says that angle 1 plus angle 2 is 180. Well, here, notice that what we did was, we said that angle 1 is congruent to angle 3. We said angle 3 plus angle 2 is 180. And now, since angle 1 is congruent to angle 3, we can just substitute. So now we're just substituting. Again, because we're proving the same side interior angles theorem here, we are not going to use same side interior angles as any of our reasons, just as we did with alternate interior angles. Alright? Okay, so let's look at problem at the bottom. It says, notice how the first property is a postulate while the other two are theorems. The difference is that a theorem is able to be proven while a postulate isn't. Remember, those are just facts that we accept, but we can't necessarily prove it, but it hasn't been disproved, and no doubt that they've tried. Okay, so let's look at these two problems at the bottom here. First problem, we want to find x and y. Again, notice these arrows. These arrows are telling us, hey, these are parallel lines. Okay. A lot of times when I see those, it helps me a little bit just to continue those so it looks like the diagrams that we have when we're learning this stuff. Okay. Alright, so first thing I like to do is look at information that they gave me and see how that's going to help. They gave me that this angle is 70. Hopefully you notice that, hey, this is in the bottom, or you can say the top left of our transversal and one of our parallel lines. What's in the top left of our transversal and our other parallel line? Well, in this case it's x. Okay, so these are corresponding angles, and we know that corresponding angles are congruent, so we know that x is 70. Okay, now I'm going to use my information that I know that, hey, these three angles make up a straight line. So that must mean that those three had to add up to 180. So I'm going to say 70, because I know what x is now, plus 50 plus y equals 180. So 120 plus y equals 180. And that means that y will equal 60. Let's look at the second problem just so I can make, oops, okay, that was lower than I thought it was. Let's look at the second problem so I can make sure that we are careful with these problems. In the second problem, it says find the values of the variable. We have 15x plus 7 in one angle and 18x minus 14 in the other. Typically, people will jump straight into trying to do this problem because they're in a kind of a groove or something. Always check to make sure that we know the information before we get going. In this case, we need to know that those two lines, that the transversal is intersecting parallel lines. For this problem, they did not tell us that these two lines are parallel. Okay, visually we might think that we see two parallel lines, but we have to make sure that we know that they're parallel before we can assume these alternate interior angles will be congruent. Okay, so quick clarification, these are still alternate interior angles, but alternate interior angles are only congruent when a transversal intersects parallel lines, and that information is not given that our lines are parallel. So at this point, it's not possible. You can say not possible, you can say not enough information, which I will abbreviate here. Okay. Alright, so hopefully throughout this video you've seen some special angle pairs, you know how to use their properties, and you are ready to kind of build on this for the chapter. Alright, see ya.